All right, everybody. So here we are, one of the last assignments of the year. We are talking about kinetic energy equations. Okay, so this is assignment 3.6. This is what it looks like. So the first thing that I kind of want to explain is how this 3.6 ties in with 3.5, this kinetic energy experiment. So if you did this experiment right here with the ball rolling down the ramp, what you probably have found is that when you plot it out, that it is a quadratic relationship, okay? And you probably got a C value close to 0.015, okay? Now, what does that represent? Or sorry, 0.014. Well, if you look at it, the mass of the marble was 0.028 kilograms. So the C value is 1/2 of this. So that means this stays as v squared. This is 1/2. This is the mass. So this right here is the equation that we're going to be using to calculate the kinetic energy of an object. Now, this is like in general. I use ball and ramp here a bunch, but it can be in general. So I'm going to go real quickly how to do these different equations real quick using this equation right here. Okay, so in the first one, a 3-kilogram ball is on top of a ramp. If it has a velocity of 8.50 meters per second when it exits the ramp, how much kinetic energy did it have? Okay, so first thing is identify my variables. I have mass, 3.00, velocity, 8.5, technically it's 8.50, and I'm solving for this. Okay, I'm solving for 108, so this is gonna start like that. So, again, rewrite my equation. Now this is kind of easy. I just input everything. 1/2 stays as 1/2. My mass is 3, and my velocity is 8.5. Okay. Now, if I want to do one extra step, what I would do first is I would leave 1/2 as 1/2. I would leave 3 as 3, and I would do 8.5 squared. So I'm going to grab my little calculator real quick. I'm going to say, okay, 8.5 squared equals 72.25. Okay. That times 3 times 0.5 equals 108. Okay, so my final answer here is 108. So 108.375. But what I do is I always use the correct number of significant figures in my final answer. That's kind of how I show that my final answer is all good. Okay. So it's going to be 108 point, actually just 108, because this has 3 digits, this has 3 digits, so this is going to have 3 digits. Cool. Cool. That's that. This problem, exactly the same. You're basically just solving for the kinetic energy. Okay. Now with problem 2, you're actually solving for the mass. So you put everything in that you know, and then this right here is going to stay as m. And what you're going to do is after you square this value, you're going to take this value and this value, multiply them together, get this one. Then you divide both sides, and that's how you get the final one. Okay. On this last one, same kind of thing, but you are solving for velocity. Okay, so this is just practice on using this problem right here. Now the second part is a little tricky. Basically, the second part is kind of like a reproduction of the lab, but in equation form. And what you have to understand is I'm going to give you a problem, and then you're going to take that problem and you're going to solve for, in this first case, kinetic energy. And then you're going to assume that all the kinetic energy that the marble had at the end of the ramp, it started as potential energy. We're going to assume there's no friction and there's no thermal energy. So let's take a look at this one. A 3-kilogram ball is on top of the ramp. Okay, so the mass is 3 kilograms, and it has a velocity of 8.5. Okay, so 8.5. How high was it? So there's 2 steps to this. We first have to get the kinetic energy, which, by the way, this is the exact same one I just did right here. And then we're going to use that value to get the potential energy. So I'm just going to start with this part right here. Okay, so I'm going to be using this equation right here for potential energy. Okay, but I'm going to be using this number as the potential energy. So 108 comes down here, and that equals to mass times gravity times height. Well, we know that the mass hasn't changed. It's still the same 3 kilogram ball times 9.8 times the height. This times this is 29.4, and then I divide both sides by 29.4 and I get 3.7 meters. That was my height, okay? Then you're doing something very similar. This one right here, it starts the same as this. So you can just take this one and copy it and paste it right here. Now, I'm gonna do another one right here, and I'm gonna go the other way, okay? So if I know that it starts at 3 meters and it's a 1.5 kilogram ball, how fast will it go? So, okay, so it starts as gravitational energy, cool. So m times g times h, the mass is 1.5, the gravity is 9.8, the meters is 3. So I multiply these 3 together and I get 44.1 joules. Cool. So that that's up above, then it's going to go down, and that's going to turn into kinetic energy. Okay, so 44.1 is the kinetic energy now. The mass hasn't changed, it's still 1.5, and now I'm going to solve for velocity. Okay, so I start to input what I know, 44.1 here, 1/2 here, 1.5 here. I'm going to multiply these two, I get 7.5. I divide both sides by 7.5, I get 5.8, and I take the square root, and I get my final answer to be 2.42 meters per second. Cool? Cool. The quiz that is actually just entering these answers. So when you get an answer for these right here, you're just going to enter those answers on the quiz, and it'll show you how you do. And if you have any questions, let me know. All right, I'll talk to you all later. Thanks for tuning in.